Okay, welcome back to our flipped chemistry classroom. And today we are talking about balancing redox reactions in acidic and basic solutions. So the process begins the same way. Anytime we're balancing a redox reaction, the very first thing we want to do is assign oxidation numbers. So step one, assign oxidation numbers, and we're going to use an example equation as we go through this process today. And so our example equation is going to be iron 3 oxide, which is a solid reacting with carbon monoxide, which is a gas, to form solid iron and carbon dioxide. Let me move me out of the way. Okay, so the very first thing we're going to do is assign oxidation numbers to all the elements in our reaction. So we're going to, this is an ionic compound, so oxygen is -2, and iron is therefore going to be +3. Okay, so we've assigned oxidation numbers based on the known charge of oxygen and iron. For the carbon monoxide, we're going to rely on the fact that oxygen is -2 when it's in compounds, which means that the carbon has to be a +2. And then here we have iron by itself, so its oxidation state is 0. And again, the oxygen is -2, and the carbon therefore must be +4. So we've assigned our oxidation numbers, and we're going to determine what's oxidized and what's reduced. And so I'm going to look at oxidation numbers, and I'm going to recognize that anytime the oxidation number goes down, that's because that gained electrons. So we now know that the iron is reduced, and we can see that each iron gained 3 electrons. And we can see that copper went from +2 to +4, which means that it lost electrons. Each carbon lost 2 electrons, and so it was oxidized. And so our third step is going to be to write the oxidation and reduction half reactions. And so my reduction half reaction is going to be Fe2O3 forms Fe. And we're not going to worry about all the other stuff. We just want to bring in the thing that is being reduced and anything it is bonded to that is not dissolved in solution, that's not a spectator ion. So we're going to hold on to that Fe2O3 because that's a solid. Okay, and this is my reduction half reaction. We don't actually have to label these, it's not important, but I like to label them so that I make sure it's one of the ways that I'll double check. And then my oxidation half reaction is going to be carbon monoxide forming carbon dioxide. Okay, so first thing that we need to do, having written those half reactions, is to balance the elements other than oxygen and hydrogen. So I have 2 irons here. I'm going to put a 2 in front of the iron on this side to balance the iron. I'm not going to worry about the oxygen yet. Here I have one carbon in the reactant side, one carbon on the product side, so I don't need to make any changes. And I'm here, so it's out of the way. Okay. Having done that, I am now going to balance oxygen, but this is a whole new concept. We're going to balance oxygen by adding water. So I have 3 oxygens on this side. So in order to have 3 oxygens on this side, I'm going to add 3 water molecules. And here I have 1 oxygen and 2 oxygens, so I'm going to add water on this side. Now we're going to balance hydrogen by adding hydrogen ions. This is why we say this is happening in acidic solution, because that means that there are hydrogen ions available. So on this side, I have 6 hydrogens. Here I have none. So I'm going to go ahead and add 6 hydrogen ions to this side. And here I have 2 hydrogens on the reactant side and none on the product side. So I'm going to add 2 hydrogens to the product side. Now for step 7, we're going to balance charge by adding electrons. And we always add electrons. We never subtract electrons. So the total charge on this side is 6, positive 6. The total charge on this side is 0. So I'm going to go ahead and add 6 electrons. Total charge here is 0. Total charge on this side is positive 2. So I'm going to add 2 electrons. Now, if we go back to our original, so this is our first checkpoint. If we go back to our original equation, we can see that we said that iron gains 3 electrons, but there are 2 irons. So each iron must gain 3 electrons. So that matches up with the 6 electrons that we've added here. And we said that each carbon loses 2 electrons, and that matches up with the 2 electrons that we have here. So now we've balanced our charges by adding electrons. But in order to combine these 2 reactions, we're going to have to multiply one or both equations by an integer in order to make electrons lost equal the electrons gained. All right, so if we look at our example here, we're gaining 6 electrons, we're only losing 2. So I'm going to multiply this whole equation by 3, so that then I have 3 carbon monoxide plus 3 water yield 3 CO2, carbon dioxide, plus 6 hydrogens plus 6 electrons. We're almost done. So now we are going to combine the equations, combine the half reactions. And that's going to give us iron 3 oxide plus 3 carbon monoxide plus 3 water plus 6 hydrogen plus 6 electrons yields 2 iron plus 3 water plus 3 carbon dioxide plus 6 hydrogens plus 6 electrons. And step 10 is to simplify. And we can see that we have 6 electrons on this side and 6 electrons on this side. That's just not going to work, are they? 6 electrons on this side, 6 electrons on this side. We can simplify and get rid of them. We have 6 hydrogens on the product side and 6 hydrogens on the reactant side. We can simplify and get rid of them. We have 3 waters on the product side and 3 waters on the reactant side. Simplify and get rid of them, so that our final equation is iron 3 oxide plus 3 carbon monoxide yields 2 iron plus 3 carbon dioxide. And this is a gas, and this is a solid, and this is a gas, and this is a solid. So those are the steps for balancing in acidic or neutral solution. If we are balancing in basic solution, there's one last step at the end, and that's to neutralize the hydrogen by adding hydroxide. So let's walk through one more practice problem. I'm going to keep those steps over here so that you guys can see them, hopefully. There we go. Now that I've made everybody seasick, let's take a look at a practice problem. So we're going to go with the permanganate ion in solution reacts with the oxalate ion in solution to form manganese 4 oxide, which is a solid, and carbon dioxide gas. So again, we're going to assign oxidation numbers. So oxygen is -2. That's a total of -8 plus something makes -1. Manganese must be a +7. Oxygen is a -2. There are 4 of them. -8 plus something is -2. Both carbons together must be +6. That means each carbon must be +3. And well, we're gonna have to do it this way. Okay. Over here, oxygen is still -2. That means the manganese must now be +4. Oxygen is still -2. That means the carbon must now be +4. So we've gone from +3 to +4. So our carbon has been oxidized. It's lost 1 electron. And our manganese has gone from +7 to +4. It has been reduced. It has gained 3 electrons. All right, so we've assigned our oxidation numbers. Now we're going to determine what's oxidized and what's reduced. Okay, we've done that. Now we're going to write our oxidation and reduction half reactions. So I'm going to take the permanganate ion and the manganese containing product, and that's going to be the manganese 4 oxide. And my other half reaction is the oxalate ion becoming carbon dioxide gas. So next step, balance the elements other than oxygen and hydrogen. So manganese, I have 1 and 1, don't need to do anything there, but I have 2 carbons and 1 carbon. So I'm going to use a coefficient to make that be 2 carbon. Slide this over here, sorry. Okay. Now we've balanced our elements other than oxygen and hydrogen. So we're going to balance oxygen by adding water. So we have 4 oxygen in the reactant side, only 2 on the product side. So I'm going to add 2 water molecules to the product side. Here I have 4 oxygens and 4 oxygens, so I don't need to do anything to that one. Now we're going to balance hydrogen by adding hydrogen ions. So I have 4 hydrogens on the product side, so we're going to add 4 hydrogens to the reactant side. And next we're going to balance charge by adding electrons. So the total charge on this side is -1 plus +4 gives me +3, and total charge on this side is 0. So I'm going to add 3 electrons. And that, again, we're double checking, matches what we predicted would happen with it gaining 3 electrons. And now with our oxalate and our carbon dioxide, total charge on this side is -2, total charge on this side is 0. So we're going to add 2 electrons to the product side. Now we said that each carbon lost 1 electron, but there are 2, so it makes sense that we have 2 electrons here. Now we're going to multiply one or both equations by an integer so that electrons lost equal electrons gained. I have 3 electrons here, 2 electrons here. So I need to multiply this by 3. And I'm going to multiply this one by 2. And so we're going to have 2 permanganate ions and 8 hydrogen ions and 6 electrons, forming 2 manganese 4 oxide and 4 water. And our oxalate becomes 3 oxalate ions, forming 6 carbon dioxide molecules and 6 electrons. And now we're going to combine our equations. We're going to combine those half reactions so that we have 2 permanganate ions in solution plus 3 oxalate ions in solution plus 8 hydrogen ions plus 6 electrons yield 2 manganese 4 oxide formula units plus 6 carbon dioxide molecules plus 4 waters plus 6 electrons. Oops, I'm in the way again. Yeah. Okay. So once again, we can see that the electrons are the same on both sides and they're going to cancel out. Now, because this is happening in basic solution, we have one more step we have to do. There are not free hydrogen ions floating around in basic solution. So what we're going to do is however many hydrogen ions we have, we're going to add that many hydroxide ions to both sides. Now, 8 hydrogen ions and 8 hydroxide ions become 8 waters. And we still have the oxalate ions and the permanganate ions forming the manganese 4 oxide and the 6 carbon dioxide and the 4 water and the 8 hydroxide ions. And now we can simplify a little bit. We have 8 waters on this side and 4 waters on this side. So this is going to become a 4. And our final reaction is 2 permanganate ions plus 3 oxalate ions plus 4 water molecules form 2 manganese 4 oxide and 6 carbon dioxide and 8 hydroxide ions. And that is where we would leave that one. Okay, you have 6 practice problems. I look forward to seeing your work and let me know if you have any questions. Thanks.